before we begin, I want to provide a little bit background on the Chainstay subassembly and why I draw it separately. So the Chainstay subassembly is the most important part of the bike, and it requires all of the engineering. It handles the tire clearance, the drivetrain clearance, the brake standard, and then the dropouts and the axle. So all the most complicated parts of the bike. If you have a well-engineered Chainstay subassembly, you can reuse it on different designs, and also it makes the bike come together really easily. Now I'm going to show you how to draw this in the tutorial, but also let me show you how I use it. So here's an example of a bike that is a gravel bike, and it's missing the Chainstay subassembly. And so if I drag in the drawing that I created earlier, and then I'm going to join it to the sketches, hit join, and there, click OK. Let's see. Now you see the Chainstay subassembly is in the CAD of my gravel bike, and we could tweak it a little bit here. The seat stays are a little bit too far back, so let me edit the sketch, pull these in, 12mm offset. That looks pretty good. And then the benefit of doing this Chainstay subassembly separately is if I change the geometry of the bike, for example, if I wanted a really deep bottom bracket drop, then the Chainstay will move with the geometry of the bike. And so once you've engineered this Chainstay subassembly, you could reuse it for different geometries. Obviously, you have to keep the chainstay length the same and the tire clearance the same, but other than that, you can use it for different sizes or different designs. I'll also note that I'm going to drop all of these files onto the custom frame forum. So if you are having trouble following along, I suggest you can download these and reverse engineer how I drew them. I wanted to take a second to thank you guys for watching my videos. These videos take a while to make, but I enjoy doing it. And so if you like what you see, I hope you can like it and subscribe to the channel. I think that would help promote the video. I'm working on a really cool video project right now where we're going to design and engineer a custom frame and send it out to a contract manufacturer to get it made. So I think you guys will really like that video, and if you subscribe, you'll get notified for that. Anyway, thanks everyone. Let's start with the 2D clearance drawing. So start sketch on the top plane, and I'm going to draw the center line and an axle. I use the midpoint constraint to constrain the axle to the center line. Dimension this one 142 for the axle spacing, and the chainstay length we're going to start with is 430 millimeters. And then I could select these. I guess select this one, make it a construction line. And now I'm going to draw the drivetrain clearance, and I'll flash on the screen the clearances that I'm using, and also a link to where to find these drawings. But in short, we're going to use GRX 1x chain line and crank arm clearance. So I'm going to do rough sketch of the crank arm and the chainring, and then we're going to add dimensions to these. So for 40 tooth GRX chainring, this dimension here is 84.6, and the distance from the inside of this chainring to the center line is 46.7. Oops, 46.7. And then we're going to dimension the crank arm, and the length of the crank arm, the biggest crank is 193.4, and the distance from the center is 60 millimeters. And then now you notice these are still floating. We're just going to give these dimensions so they turn black. So this is 15 millimeters, doesn't really matter. And I usually use 8 for this one, also doesn't really matter. All right, so now we have the crank arm and chainring, and we're going to draw the tire body. So we're going to use the drawing for a WTB Riddler, 45 millimeters, 700 by 45 millimeters, and I'll flash on the screen the drawing for that and also a link to where to find it. Actually, there's not that many tire body drawings out there, and the best thing to do is to have a tire that you have already own and then measure it. So anyway, we'll start by drawing the main body, and we're going to draw a point right here, and now we're going to draw the tread pattern like that, and starting with tangent there, line here, and then I'm going to trim away this outside body. So now we have a representation of the tire body. This is going to be 45 millimeters, and then the diameter is, let me double check. The diameter is 716 millimeters. So dimension here, 716 divided by 2. And the knob height, or the knob height here is defined as 11 millimeters. So that is our tire. And now we want to create a little clearance body to avoid. And so we're going to use the offset tool and do 6 millimeters of clearance. Enter, and I'm going to close off this body here and here. And then if you want, you can also add a little clearance body here to remind yourself to avoid touching this chainring. Generally, this position is pretty relaxed. This is a very conservative dimension for this chainring edge, but I'm going to put this as 3 millimeters in diameter, so roughly 1.5 millimeters of space right here. And yeah, that looks good. And this is the 2D tire clearance body, or sorry, this is the 2D clearances for your tire and your crank arms. Now let's finish the sketch. Rename this clearances. Here I have these UDH dropouts, which are my own design, and I'm calling these open source because I'm releasing the file for whoever wants to use them. So I'm going to start by selecting this, dragging it into my drawing, hitting OK. Now this is something new. I don't know if this is just a new feature or something, a new setting in my Fusion, but the first part that I drag in is grounded. So I'm going to right click this and click unground from parent, and that should allow me to move it. Now I want to join it to the edge of, or the end of this sketch here. And this is what I find people struggle with. So let me show you a little trick. If I click join, I want to select the plus sign on this face of the dropout. So that's like the inside face of the axle. But the problem is when I hover close to it, it starts selecting other features. So the trick is to hold control on the keyboard. And as you're holding it, it allows you to hover around, select different points. And so now I can move to the center and select this plus sign. And same with this axle, I can hover over the axle, hit control, and it allows me to jump along these little control points. I want the end of this, click OK. I'm going to flip it and click OK. And now that is the right spot. Same with the non-drive side dropout. I'm going to drag this in and then click OK. Select the inside face here. So I'm going to hit J on the keyboard for join. And again here, you make sure to select the inside face and hit control and then jump to the center point. If you start trying to select the different points, you'll see it might choose the chamfer or the edge, and you just don't really have good control over what you're actually selecting. So again, hover the inside face, hit control, jump over here, select it, and then now go to the end of this axle and hit control, jump to the end, click. You see here it's the wrong orientation, so I'm going to flip it. And now it's upside down, so I'm going to rotate this 180 degrees and click OK. Now, I don't have to worry too much about clocking these dropouts the correct way because I knew how I drew them in the original drawings. But one thing you could double check is that the way these dropouts are designed is that this flat surface is parallel to the center line of the axle to the bottom bracket. So this is clocked correctly. Next, we're going to draw what I call the bottom bracket dropout sketch. And that allows you to position your dropout hoods and also the bottom bracket with the chainstay center line. So let's start with a sketch on the front plane or the right plane, however you start it off. And we're going to draw, first we're going to project the actual, or what I like to call the virtual center line, which is the horizontal line from the dropout to the bottom bracket. I'm going to draw a bottom bracket here, and we're going to use a T47 bottom bracket, which is 52 millimeters in diameter. Let's give this a little thickness. This doesn't really matter, but I'm going to call this 3 millimeters thick. And then we're going to draw the hood. So because I designed these dropouts, I know that this is 38 millimeters in diameter, I guess 38.1 technically. And it is, so we want to overlay this on the hood. So you can see here, I know that I drew this along the center line and exactly 6 millimeters offset, or sorry, 7 millimeters offset. So now we have the exact hood location for the chainstays. So that is, let's see, let me hide the clearance sketch. So this is the representation of our bottom bracket and our dropout hood. And now we need to place the actual chainstay center line. Again, there's the virtual chainstay center line, which is from the axle to the bottom bracket. That is like the theoretical chainstay. And then we need to create a actual chainstay, which is going to be where our physical chainstay is going to be. And in this case, in order to meet UDH specification, we need to offset the chainstay 3.5 millimeters up from the axle. That allows it so the chain or the derailleur pulley doesn't hit. So I'm going to offset this one 3.5 millimeters, 3.5 here. And notice here there's a tangent constraint. This allows me to offset it from the center line. And I'm going to make this one meet the center line of, or sorry, the center of the bottom bracket. So it should turn black. And again, we have the virtual in purple and then the actual chainstay plane in black. And I'm going to finish the sketch and I'm going to rename this BBDR for bottom bracket dropout sketch. Now that we have this bottom bracket dropout sketch, we can draw a plane or create a reference plane, which we're going to draw our chainstay center lines on. So if I go to construct and plane at an angle, and I'll select the black line, the actual chainstay center line, and hit 90 degrees. And now I can draw the chainstays. So I'm going to sketch on this. And I'm going to project the actual chainstay center line. Now I can hide my other sketch. And now I have a pretty clear view of what I need to do. So let's start with showing the clearances. So the idea is I need to draw a chainstay that hits the hood of the dropout here and avoids this crank arm and then navigates the clearance between the tire body and the chainring. So let's start. I'm going to project this axle here just as a reference, and I'm going to draw a line out here, an offset and an angle or angle reference. And it's probably easier just to watch me do this and try to replicate it on your own. Every single chainstay is slightly different, and it's kind of an art where you place the bends. So I'm going to do my best to do this quickly. Start with a segment here, and then let's draw a line here and a line here. That, and make this one vertical. So that's kind of the shape of your S-bend. Let's get rid of this. I don't want this perpendicular. Let's make this horizontal. And now we need to add the center or the bend radius. So if I add the fillet tool, select this point here, select this point here, and based on our tooling, we know that we could bend a 230 millimeter centerline radius. Like that. There we go. Let's make this a construction line. Okay, it's getting there. Make this construction line. All right, so another trick we're going to use is a parameter for the chainstay diameter. And for a titanium frame, you typically use a 7/8 chainstay, which is 22.2 millimeters. So I'm going to create a new parameter called chainstay diameter and call this one 22.2. Now, what we can do is we can create kind of a representation of the chainstay in this 2D sketch. So if I select my center line, and I'm going to do chainstay diameter divided by 2. So that's the inside. Make these all constructions. Construction. Create another offset, and we'll call this one negative chainstay diameter divided by 2. And then like that. So I know from previous experience that this angle here works well if it's 12 millimeters for gravel bikes. And then now we can kind of place it right in the center of the hoods. So like about there, and give this guy a dimension here. Call it 19 millimeters. And then we can start adjusting the bends. So this first bend here, we need to clear the crank arm. So this is probably the right spot for it, right there. And how we can give that dimension is we can say that this thing is 41 millimeters. Let's do it 42 millimeters from the center line. So that bend looks good. And now we need to place this bend and this angle here. So this is where it gets a little hard. We're going to need to dimple the inside of this chainstay for this tire clearance, and we're going to want this guy to kind of sweep across and just miss this clearance right here. Another complication is that for the Cobra chainstay bender, there's a minimum distance here that has to be satisfied. You can't have this distance between the S-bends shorter than 75 millimeters. All right, so that got a little more complicated than I wanted to, but you can see hopefully how you kind of tweak the chainstay bends to get what you want. Now that we have the center lines, we can create the chainstay and bottom bracket. We're just going to create a pipe and select the center line here. The diameter is going to be chainstay diameter here. And now we're going to cut the chainstays. So you see our bottom bracket dropout sketch right here. Click extrude, select the dropout body, and select the bottom bracket body. Make sure you select these little guys here. And then we'll trim it all the way through and do 2 sides. So now we have this chainstay trimmed to fit the bottom bracket. We're going to select that body and then we're going to mirror it. Mirror plane here, just like that. That's the other chainstay, and then we're going to draw the bottom bracket. So if I do sketch here, or sorry, not a sketch, I already have it here. It's our bottom bracket. We're going to extrude here, just like that. Do symmetric, whole length, and we're going to do 85.5, which is T47 internal bearings. Okay. Now we're going to draw the Flatmount bosses. So we're going to start by showing the centerline sketch, or sorry, the clearances sketch with the axle. And we're going to create a plane along the path right here. Basically, we want a plane right on the face of this axle. Now, it's important that we don't just select the dropout, because then this plane will be linked to the dropout. And if we change the dropout, then it's going to break our sketch. So it's really important that you reference the clearance sketch of this drawing. So plane along path, select the axle, and then push it all the way to the end and click OK. Now we're going to draw a Flatmount 160 sketch. So the height of a Flatmount 160 boss is 21 millimeters. And then this distance is 45 millimeters. And this distance is 34 millimeters. This is the sketch that you want. And then finish here. Now we're going to draw the bosses. And so I'm going to have a plane at an angle and select, I don't know why I automatically selected that line. We don't want that. We want this one right here. And do 90 degrees. Now we're going to sketch on this. And we're going to project this line for reference. So project P, hit enter, make this a construction line. Now the bosses of a flat mount are offset from the axle face by 7 millimeters. So I'm going to draw a little line here, make it a construction line, another one right here. And then these are 16 millimeters in diameter, and they're offset by 7 millimeters. I'm going to draw one, and I'm going to set the other ones equal. So set this one equal, and this distance equal. So that's the correct location for the bosses, and I'm just going to draw the slot for the bolts. I'm going to start with the center point slot. Draw a rough sketch, same with here. Set the distance or the length of slot equal and set the diameters equal. Now I know this length is 3 millimeters roughly, 2.5 to 3 millimeters. And the diameter of this slot, or the width of the slot, is 5.2 millimeters. So yeah, we have a fully dimensioned drawing. Finish sketch. And now we can create, I guess first we'll trim our chainstay, and then we're going to create the flat mount body. So it looks like these need to be long enough so that you can weld on the bottom, and probably 35 millimeters should be long enough. And let's not get sloppy and rename these sketches. This is flat mount location, and these are flat mount bosses. Hide these sketches. And yeah, I think we're done. Let's review really quick. Show my clearance sketch. We have our flat mount bosses in the right spot. We have our chainstay that lands on the dropout, that avoids the crank arm clearance, avoids the chainring clearance, and it wraps around the tire right here. And we're going to need to dimple this in real life by 5 or 6 millimeters, but that should be doable. And oh yeah, and it lands on this bottom bracket with enough room to weld the chainstays. So yeah, that is our completed gravel chainstay subassembly.